Hello, good afternoon, math class, or good evening. We are working furiously to get all our lectures online for y'all. So listen, I'm going to go over exactly what I go over in class for chapters 15 and 16. You know I'm available, text, we'll FaceTime, we'll do whatever we have to do to get through this. So let's just get going. Chapter 15, if you'll open your books with me, we'll go over some things. It's all about insulin administration. Insulin's given for our diabetic population. You will give a ton of insulin in nursing. You need to understand it. Um, our book starts out on page 15 down persons with type 1 diabetes. There's type 1 and type 2. We need to know the difference. Type 1 diabetes uh, is the person that's unable to produce endogenous insulin, so they must inject insulin to survive. Type 1 diabetes, they always, always, always have to have insulin. Type 2, a lot of them have the pancreas still that it may produce, so they can take some oral hyperglycemics. They can sometimes control it by diet. Gestational diabetes is just the presence of diabetes during pregnancy, usually will resolve after pregnancy. So those are three terms when diabetics that you need to understand. Look at the glossary of terms up there. Exogenesis and endogenesis. Endogenesis derived or produced from inside the human body. So type 1 cannot produce its own insulin. Type 2 um, could produce its own insulin. Um, Diabetes mellitus is managed with diet, exercise, and medications, all three of which are equally important in managing blood glucose levels. So we need to understand that about diabetes. Most of y'all are going to know somebody that is diabetic. So you kind of have some kind of concept of this. In nursing, though, like I said, we will talk about diabetics a lot. Carbohydrate counting is very important with diabetics because it's all about the carbohydrates, how fast that insulin goes up and how fast it goes down. Well, I'm on page 294. There is some insulin. It talks about down at the bottom, beef and pork side or pig sources is how they derive the insulin. Um, Now insulin is produced in laboratories using recombinant DNA technology, so we don't use as much of animal byproduct insulin as we used to. The amount of insulin, this is reading from page 294 down at the bottom, the amount of insulin that an individual with diabetes needs depends on numerous factors: the type of diabetes, the presence of other diseases or illnesses, and the individual's body weight. So today, if you were asking on a test, most of our insulin comes from the recombinant DNA technology. So that's a new technology that's come about over the last 20 years or so that we don't have to rely on pork or beef insulin. There are certain populations of people and certain cultures that would not take that because it's against their religious beliefs. Nurses need to know this is on page 295. Insulin is a drug that when you inject it, you have an onset of it, you have a peak of it, and then you have a decline. It goes up. That's the onset is when it starts going up or doing its deal, whatever it's going to do, Laura, and then it peaks out at this, and then it starts dropping off. So the action of insulin is very important to understand as we give it to our patients because when it starts dropping a lot of times, once it's done its peak and comes back down, the glucose levels can go back down or go back up, whichever the case may be. Um, Insulin, as y'all know, as I said earlier, insulin is derived outside of the body. It's called exogenesis. Insulin that is inside the body is endogenesis, and that's made by our pancreas. Um, there's different types of insulin. Most type of insulin come in a concentration of 100 units per 1 ml. So they're given in these little bitty syringes, and if you will turn over in our book, there's a page that shows some little bitty syringes, and those are called insulin syringes. They're generally orange. They're page 301. U100 is an insulin syringe. U50 is an insulin syringe. So we'll get to that in just a minute, but I just want to point out on page 301, you see the insulin syringes. Um, with certain types of insulin, um, it talks about insulin aspart on the insulin types. That's Novolog. The onset is 10 to 20 minutes. The peak is 1 to 3 hours, and the duration is 3 to 5. So the recommended timing of administration is 10 minutes before a meal. You don't want to give it and then wait an hour to eat because say if their blood sugar is a little bit high and you're giving this insulin to bring it down and they don't have any food on board, then it's going to drop them too low and they're going to become hypoglycemic because we give insulin to prevent hyperglycemia. Hyper meaning too high of glucose, hypo meaning too low of glucose. The next one, the insulin Lispro or the Humalog, we give a lot of it. It's a rapid acting insulin. It will act within 5 to 15 minutes again. So we want to do 15 minutes before meals or immediately after a meal to be sure they're kind of sustained when this insulin starts acting. So we need to understand that. We have some long acting insulin. We have some short acting, intermediate acting. I want y'all to review those. Down at the bottom, insulin uh, Gloragine or Lantus. Lantus is the term that you will hear a lot. It starts to act in 3 to 4 hours. There's no peak and it lasts for 24 hours. So with that type of insulin, we really pretty much give it all at the same time of day. So a lot of times when you get in nursing school, you're going to understand this more, but we just need to know that insulin always, nurses need to know, as it said at the top, that they have an onset, a peak, duration for the action of insulin. Um, Insulin on page 296. I want y'all to read through the yellow box, managing hypoglycemia, just some good information for you to know. Insulin orders down there, insulin may be ordered in a number of ways on a routine or fixed schedule, to be given before a meal, to be given after a meal as a correction dose, using sliding scale, using a combination of methods. So therefore, we need to know how to give it. Um, a lot of your insulin, like your Humalog mix is 75-25 or 70 Novolog mix is 70-30, are usually ordered on a routine basis. And like I said, once you get into nursing, you're going to understand a little more about this. But not all insulin is the same. Insulin all has something different. So we all have to be really, really familiar with what we're given and when we're given and what it's going to do to our patient when we give it. So pre-meal administration of insulin. Many providers provide the patients inject rapid or short-acting insulin just before their meal. You will know that from the order, but also you need to be sure that that is correct when you're given something. Post-meal administration of insulin, rapid-acting insulin may be occasionally be administered after a meal because the patient reacts so fast to it, they can get really weak and shaky because their glucose is going down too fast, their blood sugar is dropping too fast. A correction dose of insulin is, this is all on 297. Correction dose of insulin are administered when the patient's blood glucose level is expectedly high. In such cases, routine pre-meal doses of insulin are not enough to reduce the blood flow or the blood glucose level to a normal. The correction dose of insulin varies depending on the severity of blood glucose reading. And that kind of leads us into a sliding scale. So we want to know that correction doses of insulin are administered when the patient's blood glucose level is expectedly high, unexpectedly high. So that's what the correction dose, and then we talk about a sliding scale. This will be ordered by your physician, and what that means is, like if you look at under the sliding scale, is blood glucose level less than or equal to 110, you would give no extra insulin. A lot of times these are ordered before meals and at bedtime. They have their regular dose early in the morning, and then if they're still running high throughout the day, then we're going to give a little bit of extra. Then that next one, blood glucose level between 111 and 130, you give 3 units. Blood glucose level between 131 and 150, you give 4 units. So on. That's just how you would read that. Every sliding scale may be a little different, so you have to refer to your order to be sure that you're reading it correctly, and that's what you would give. So effective management of blood glucose levels generally involves a combination of methods. So just know that sometimes it takes a lot of tweaking to get these insulin patients back in shape as far as getting their glucose under shape. So let's read on to page 300, insulin delivery systems. We have sub-Q insulin delivery systems. Sub-Q insulin may be administered periodically, or continuous insulin that is given periodically is administered with single-use syringes or insulin pen. For insulin that's derived continuous, they probably have an insulin pump. And most of y'all have seen insulin pumps. They're very widely used in our market today. Administer insulin using syringes and vials. Um, Syringe caps, I'm reading number one right under that. Syringe caps of U100 syringes are orange. U500 insulin syringes are green. Um, so just know there's a purpose for these cap colors. You would also want to always check your dose. If you were given, there's U100, U50, U500, which you don't really see a whole lot of that one. But if you were giving a dose of insulin and they had ordered 43 units of the insulin to be given, you don't necessarily want to put it in a U100 because you can actually get too much. So you try to match your dose. If you're ordered 43 units, you would probably want to do it in a 50 unit syringe. Of course, if you were ordered anything over 50 units, you would have to use that U100 insulin syringe. This talks about the needles with insulin syringe are very fine and short, ranging from 27 to 31 gauge. Um, most of these insulin syringes have a special coated needle that makes it easier to give and less painful because diabetics, let's face it, have to give themselves a lot of insulin. Um, so guidelines for moving insulin from a vial. That is in box 15.3. I wish I would read over that. That will talk to you about how to draw that insulin up. You will get into this in more in nursing. Um, Administer insulin with using an injection pen. Those are pre-filled insulin cartridges, should not be mixed together. An insulin pen is what it is, so you should not mix that with any kind of other insulin. And an insulin pen should only be used for one patient only. Don't be using the insulin pen for several different patients. So mixing insulin. Let's go to 304. This gets a little more complicated, but it is something that you need to understand. You will understand this further as you go through nursing, but you're going to be asked this again. Um, Occasionally, a patient will have more than one type of insulin order to be given at the same time. To reduce the number of injections given to patients, nurses must be tempted to mix two types of insulin together. However, only a few types of insulin, this is on 304, uh, of insulin may be mixed in the same syringe. So you have to know what can be mixed. So there's a little chart there, 15.3, insulin, glycosine with NPH. You draw insulin glycosine in the syringe first. Uh, so you just need to know which one you're going to draw first, and that's just the little thing that nurses always learn. Mixing NPH insulin with regular insulin in the yellow box. You always uh, do clear to cloudy. NPH insulin is always cloudy, and that's a longer acting insulin. Clear is regular insulin is always clear. So that's something that you will learn. You always draw clear to cloudy. So it says it, you need to read through the way that we would draw it. So the NPH is the one that's purple down at the bottom of the diagram. It is the cloudy, let's say. It's kind of like a cloudy, milky color. The regular is just a clear liquid. Okay. So look at the bottom on 305. You're going to inject the air into the NPH. Then you're going to inject the air into the regular and draw whatever dose of regular up you need. And then you're going to finish drawing, you're going to, the NPH. Um, and you'll see that cloudy infusing with that clear. The reason why we do this is so we don't uh, mitigate the action of that longer acting insulin. So that's one of the reasons that we do it like this. Be sure you read your yellow box, but just be sure that you're familiar with that little diagram for this test, okay? Um, Let me see what else in this chapter I need to go over with y'all. Your homework looks pretty straightforward. If you will look on page 312, the diabetes key points, please read through all of those. The last one, NPH insulin may be mixed with rapid acting and regular insulin. Care must be taken to avoid contaminating the bowels of insulin, as this may alter the onset peak and the duration of action. Um, Low blood sugar is one of those things that we deal with a lot as nurses. Um, if you ever had a patient that was severely low blood sugar, you might want to give some 25 mils of 50% dextrose over 1 to 3 minutes. So that will be something that a lot of times we have to do to bring their blood sugar up, because sometimes with insulin we lower their blood sugar way too much. And you have to know that abnormally high blood sugar, the term for that is hyperglycemia. Abnormally low blood sugar is hypoglycemia. So just know with hypo, if we have somebody that's really severely hypoglycemic, because diabetics can go up and down, they can be really severely, if they're severely hypoglycemic, they don't always want to eat or drink because they're kind of like mentally out of it. So one of the ways that we can treat that if it's severe is it will give 25 mils of 50% dextro over 1 to 3 minutes. And that would be through an IV, or, sometimes you could do an injection quickly, but usually it's going to be through a quick IV that you do. All right, that is pretty much it for chapter 15. Please sure that you read through that, listen to what I said. Let's start on chapter 16. Chapter 16 is a little more in depth than, of course, chapter 15. Um, there is in your, this is not, I don't know if y'all can see this in your PowerPoint on chapter 16. This is in color. It's very, very good. It will help you solve problems in chapter 16. So be sure that you pay attention to this when you go through. There's a regular PowerPoint like I have given y'all, and then there's one that's just handwritten out and it's in color, and it will help y'all as you go through and try to figure out these problems. Okay, so chapter 16. Major differences between in one of the things that I want y'all to know, heparin comes in all these different ways. Heparin is giving to keep the blood thin. We give it in many kind of conditions to prevent blood clots. Um, Certain lines, like if we have a central line in, when I worked in the NICU, little bitty babies, we gave a really low concentration of heparin to keep their central lines open. It's given for a lot of different reasons. So we have to understand heparin. Major difference between there is unfractionated heparin and low molecular weight heparin. Unfractionated heparin is abbreviated UH, and low molecular weight heparin LMWH is related to the size of the molecules. Unfractionated heparin is a large molecule compared to a low molecule weight heparin. So just know that the difference between unfractionated heparin, which is UH, abbreviated UH, is a low molecular weight heparin, and then the low molecular weight heparin is related to the size of the molecule. So unfractionated heparin is the larger of the molecules, if that makes any sense. I just wanted y'all to be familiar with that. Our book starts out talking about venous thrombosis. Venous thrombosis occurs when a blood clot or thrombus forms inside a vein composed of red blood cells. Most of you probably have heard of somebody having a blood clot. That's where they would give some heparin. They would give some different types of heparin. There's different types that we can give, but we want to just kind of go through this and kind of have an overview of heparin. And I do want y'all to pay attention to this homework administration, this sheet right here. It will help you as you work your problems, okay? Heparin this is reading on 320. Heparin is an anticoagulant derived from bovine cow lungs and pig intestines. Two types of heparin are used in treating thromboembolic disorders. There are unfractionated heparin, which I told you, UH, and this is reading on 320, and low molecular weight heparin, LMWH. The difference between the two substances is related to the molecular size. Unfractionated heparin is very large molecule compared to the low molecular weight heparin. Each type has specific uses, advantages, and disadvantages. When heparin type is prescribed depends on the thromboembolic disorder being treated. That's what we would use. There is a video out that if you have time and you're really bored, because you're staying home a lot, it's called Chasing Zero, the Dennis Quaid story. It's about his babies being overdosed with heparin. It happened, and there's some other things on that video that's very good about healthcare. Now, this was in 2009 that this video was done because this is when this happened. As y'all pretty all well know, our healthcare system is going to change, evolve every day, and it has how it has in the last few weeks. It's been pretty phenomenal. But if you that Dennis Quaid video is very good about chasing zeros, how the hospitals re-evolved everything after his babies were overdosed on heparin, not given the proper dose. So you can see if you give a little bitty baby the dose that adults should have of heparin, what's going to happen? Right. They're going to bleed. They're going to die. A child, they're going to bleed. They're going to die. Start bleeding from every orifice. So heparin is a serious drug, serious, serious. So you have to know what you're doing with it. Um, you see some different concentrations here of heparin. You see 1,000 units per meal. You see 5,000 units per meal, and you see um, the 10 units per meal. So you have to know which heparin you want to give. Heparin Light Flush is 100 units per meal. So you have to be sure that you're familiar with what your order is asking and what you are to be giving. So it is imperative the correct concentration be selected. That is on 321. I want you to underline that because of high risk of adverse drug reactions associated with heparin. The Joint Commission National Patient Safety Goal 2017 was developed that delineates a hospital's responsibility for administration of unfractionated heparin and low molecular weight heparin. We should read our labels carefully. That is our number one thing that we have to do as nurses, and have to be sure that we are very familiar with what we're given and what we're doing. So let's start with a problem. I know you're excited, but I would like y'all to watch that Dennis Quaid Chasing Zero. It's a very good, very, very good video to watch about healthcare. It's just on YouTube. Okay, now we're at a point where some of y'all could probably just go right on. Look at your book, work your problems, look at your extra problems, like there's extra problems on page 323. Work every other one of those. Look in the back, look at the answers. I can go through it, but what I want y'all to do is if look at these problems, look at your homework. I will put up homework answers again. I don't want you looking at homework. I want you to submit to me your homework worked. I need to see your homework worked out to give you any credit for it. That is the only way y'all are going to learn how to do this. So please take time and look. I can go through some problems, talk you through it. I would like to talk to you on the phone. I would like to talk to you, maybe via FaceTime or something if we cannot meet face to face. And I will try to put up more instructions about how to do it. I can walk you through it with your book. If you take like problem one, a provider, this is on 321, orders unfractionated heparin, 5,000 units sub-Q every 12 hours. The pharmacy provides a 10 ml vial of unfractionated heparin with a concentration of 5,000 units per ml. How many mils per dose should the nurse draw into the syringe? Round the answer to the nearest hundredth of the mil. Again, and we're getting to the point with these problems, it's very important that you pay attention to what it says to round to. Okay, so we set up the equation using dimensional analysis. The first set of quantities will be the concentration of the heparin. So we want to know, what we're looking for is how many mils the nurse will draw up, correct? So look at that problem right there. So we said mils is equal to 1 mil is equal to 500 units, to 5,000 units. Do you see that in your problem? 5,000 units per mil. So we put 1 mil to 5,000 units. And then we have insert the next given. The dosage is to cancel the units in the denominator and solve the equation. So we have 5,000 units because the provider ordered UH, unfractionated heparin, 5,000 units. We have a dose of 5,000 units per mil. So we put 5,000 units and then we cancel out 5,000 units, and we are left with meals that will equal 1 meal. Do y'all understand that? That's how much we would draw out of that. So let's look at the next one. A provider orders unfractionated heparin 8,000 units sub-Q every 8 hours. The pharmacy provides unfractionated heparin in a 1 ml vial with a concentration of 10,000 units per meal. How many meals again with the per dose should the nurse draw into the syringe? Round to the nearest 100. So what are we looking for? We're looking for milliliters again. So what is our first sentence? 1 meal over 10,000 units. Do you see that? 10,000 units to 1 meal. But we have ordered eight. We know we're 1 meal over 10,000 units, so we're going to be looking for units. So our order says 8,000 units. So our problem, you see how it's worked. 1 meal times 8,000 divided by 10,000 gives us 0.8 meals. That's our answer. That's how much we would draw out to give. So those are pretty easy how to work. Just look at all your problems. A provider, let's look at the example 5. A provider orders dalteplin 120 IU per kg, that's international units per kg, sub-Q, eat once daily. The patient weighs 62.5 kgs. So we're going to see problems like this too. The pharmacy provides the dalteplin in a pre-filled syringes with concentrations of 5,000 IU to zero point 0.2 milliliters, or 75,000 IU to zero point 0.3 milliliters, or 10,000 IUs. How many milliliters of dalteplin should the nurse administer? Round the answer to the nearest meal. Which pre-filled syringe should the nurse pick? So we're looking for pre-filled syringes. So we know that we need 120 units kg. So we start with that because we're looking for the international unit. Um, so which pre-filled syringe? The international unit was 120 IUs per kg, and then it's times 62.5 kgs is 120 IUs times 62.5 gives us a 7,500 IUs. So if we were to select the appropriate um, syringe, which one will we select? The 7,500 IUs to zero point 0.3 mils. That is the correct answer for that. So if you're struggling, again, y'all need to work all these down here, 1, 5, and 10, and look in the back of your book. Uh, intravenous unfractionated heparin administration. Calculated intermittent bolus doses of heparin. A provider orders heparin bolus dose of 80 units per kg intravenous prior to initiating a continuous infusion. The patient weighs 56 and I'm on 324. The pharmacy provides heparin in a concentration of 5,000 units per meal in a 10 ml vial. How many meals of heparin should the nurse draw up in the syringe round to the nearest tenth? So we're looking for milliliters. We know we're looking, that's our first unit of measure. We have 1 mil to 5,000 units, and where did we get that from? Our problem tells us that, right? And then we have 80 units. That's what we are ordered per kg. And then we know the patient weighs 56 kg. So we work all that out. And so what is our nurse? What is our dose? Is 0.9. Now, why is it 0.9? Because if you look at after we worked all that out down at the bottom, it came out to 0.896. It said to round to the nearest hundredth, which would be when we round the six, we round six, six will round up. So that will be a 0 there. And then that 6 will round up to 10. So we round that 10 up to the 8 will become a 0.9, so it's 0.9 mils. And then one thing that's always important and very important with insulin and heparin, you always, always, always have another nurse check you. You do not want to be given the wrong dose of insulin or heparin because that can be detrimental, as that was talked about in that Chasing Zero video. So please watch that. So we're going to go through some more of these. You can look at example 5. A provider orders heparin bolus of 5,000 units. The pharmacy provides heparin in a concentration of 5,000 units in 1 ml vial. How many milliliters of heparin should the nurse draw in the syringe? Round the answer to the nearest tenth. So again, what are we looking for? We're looking for milliliters. So we have 1 milliliter And how do we know to start this? Is because we see in our problem, our sentence is 1 milliliter to 5,000 units times 5,000 units. So 1 mil times 5, it's 1 mil. Pretty easy, y'all, if y'all just stop and think about what y'all need to know with this. So let's go on to calculating the flow rate. That's on page 327. Let's start with problem 1. A provider orders a continuous heparin infusion to begin at 15 units per kg per hour. Don't get all afraid when you see that, because it's just going to be us breaking down problems. We've done this before. The patient weighs 82 kgs. The pharmacy supplies heparin in a pre-mixed bag of 25,000 units and 250 mils of 5% dextrose solution. Calculate the milliliters per hour and the flow rate. Round the answer to the nearest tenth. I am on page 327, number 1. So in that problem, though, there is something that we really don't need. We don't need 5% dextrose solution. We don't care about that. So just kind of ignore that. But we do care about pretty much the rest of that. So we are looking for calculate milliliters per hour. So we're calculating milliliters per hour. So milliliters per hour is what we want. So we're going to start with milliliters because it's on the top. So where does our problem, where do we see milliliters? We see milliliters in the problem with 25,000 units and 250 mils. So we put 250 mils on top to 25,000 units. And then our next thing, so we're looking for units because we have units on the bottom. So we got to go up to the top with units. It's 15 units per kg per hour. So our next thing, we're looking for kgs. So it's 82 kgs. So we multiply this all out and it gives us 12.3 milliliters per hour. Y'all, this kind of should be clicking really well with y'all. And if it's not, then we need to just kind of bump up. The only way y'all are going to learn this is to do problems over and over and over. And if you didn't know, like if you wanted to use some of these example problems, cover up the work the problem out, see if you can get the right answer, and talk yourself through it. You have to do that to learn this. You can't just think it's going to come to you if you're struggling with it. So I can go through calculating units per hour on flow rates. The first one is the nurse. This is on page 329. The nurses verify the dose of heparin infusion. The infusion pump is infusing at 9.7 milliliters per hour. The intravenous bag hanging has 40,000 units of heparin and 500 mils of 5% dextrose. Calculate the units per hour flow rate. Round the answer to the nearest whole unit. This is on page 329, number 1. So we are looking, calculate the units per hour flow rate. Round the answer to the nearest. So we're looking for units per hour. So what are we starting with? Where is the sentence we're starting with? Look real quick before I tell you. Of course, you can look in your book, but it's the 40 units of heparin and 500 mils. So that's what we're starting with. And then we know we need milliliters. So we look at where do we see milliliters? 9.7 milliliters per hour. And then we're just going to multiply this all out. It's just like following that path again. You have to know where to start, and then you just follow your pathway and you come out with your, so we know we're, after you X everything out, where you're left with units, and that's where you're looking for units per hour. Adjusting heparin flow rates, continue. This is on page 330. We want to adjust those heparin flow rates. Let me look and see how much more we got. Not very much, so y'all hang in there with me. Adjusting heparin flow rates. Increasing or decreasing the heparin flow rate when the pump is infusing in units per hour requires adding or subtracting the prescribed dosage change to the current flow rate. A patient, let's look at example 1 on 330. A patient has continuous heparin infusion running at 800 units per hour. According to the hospital's heparin protocol, the infusion should be increased by 100 units per hour. The intravenous pump should be programmed to what new flow rate units per hour? Add the prescribed change in dosage, 100 units per hour, to the current flow rate, 800 units per hour. So our current flow rate is 800 units per hour. Prescriber increased 100 units per hour. The new flow rate is what? 900. That's not really hard, right? So example 2, let's look and see if this may be a little bit harder. A patient has continuous heparin run at 623 units per hour. According to the hospital's heparin protocol, the infusion should be decreased because a lot of times with heparin protocol, you want to start decreasing it down. The intravenous pump should be programmed what new flow rate? So an example, the flow rate needs to be decreased. Subtract the prescribed decrease. 200 units per flow rate. So where are we at? We're at 623 units per hour. We need to do the decrease. It gives us 423 units per hour. Okay, that's pretty simple right there, but just kind of know what you're doing. And then, so adjusting milliliter flow rates again, changing the heparin dose when this is on page 331, changing the heparin dose when the intravenous pump is infused in milliliters per hour requires additional information. The necessary data to collect, including the following: the concentration of heparin in the bag, units per mil, the current flow rate of heparin, milliliters per hour or units per hour, the prescribed increase of heparin, usually designated in units per hour. So let's work a problem, kind of talk it out. A patient has continuous heparin infusing running at 12.3 mils an hour. According to the hospital protocol, the heparin infusion should be increased by 200 units per hour. The current heparin bag contains 25,000 units in 500 mils of 5% dextrose. The intravenous pump should be programmed to what new flow rate uh, in milliliters per hour, round to the answer to the nearest tenth. So milliliters per hour, we're going to have a rate increase, right? Because the hospital policy said the heparin should be increased by 200 units per hour. That is what we need to do. So we're looking for milliliters per hour. So we're going to start with milliliters. We see 500 milliliters to 25,000 units times, and we're looking for units now because we have 25,000 units on the bottom. So the top of the next one has to have 200 units per hour. And then, so 500 mils times 225 times 1 hour equals 4 mil an hour rate increase. So our current flow rate is 12.3 mils per hour, and we add 4 mils per hour gives us 163 mils per hour. Any problems with that one? The next problem is just the decrease. So be sure that you work those and kind of think about those as you go. Like I've said over and over and over, if you are struggling, the only way, this is an excellent book, the only way you're going to understand it is to work problems on your own. I am here for y'all. I will talk to y'all on the phone. I will do whatever I can to get you through this. But y'all have to work problems on your own. That is the bottom line. And you have to go back. And if you struggle with something, rework those problems. You can work them 10 times. That will help you get them in your head. So this is all for 15 and 16. I will be back. Talk to you later. Bye bye.